According to astronomers, aquatic planets are common in our Milky Way galaxy. In a recently published research, a team of European astronomers indicated that water can be delivered to a terrestrial planet in the form of pebble snow in the early phases of the planet's growth and development. According to the astronomers, all their data suggest that water was part of Earth's building blocks right from the beginning. And because the water molecule is frequently occurring, there is a reasonable probability that it applies to all planets in the Milky Way. The decisive point for whether liquid water is present is the distance of the planet from its star. Through the use of a computer model, the research team was able to calculate how quickly planets are formed and from which building blocks. Their results indicate that 4.5 billion years ago, millimeter-sized dust particles of ice and carbon accreted in the formation of what would later become Earth, up to the point where Earth had grown to 1% of its current mass. Our planet grew by capturing masses of pebbles filled with ice and carbon. Earth then grew faster and faster until after 5 million years, it became as large as we know it today. Along the way, however, the temperature on the surface rose sharply, causing the ice in the pebbles to evaporate on the way down to the surface, so that today only 0.1% of the planet is made up of water, even though 70% of Earth's surface is covered by water. The research team's pebble accretion theory is that planets are formed by pebbles that are clumping together, and that the planets then grow larger and larger. The water molecule is found everywhere in our galaxy, and that the theory therefore opens up the possibility that other planets may have been formed in a similar way as planet Earth, Mars, and Venus. All planets in the Milky Way may be formed by the same building blocks. This means that planets with the same amount of water and carbon as Earth, and thus potential places where life may be present or occur frequently around other stars in our galaxy, provided that the temperature is right. If planets in our galaxy have the same building blocks and the same temperature conditions as Earth, there will also be good chances that they may have about the same amount of water and continents as our planet. With our model, all planets get the same amount of water, and this suggests that other planets may have not just the same amount of water and oceans, but also the same amount of continents as is present on planet Earth. This provides good opportunities for the emergence of life. If, on the other hand, it is a random thing about how much water was present on planets, the planets might look vastly different. Our planets would be too dry to develop life, while others would be completely covered by water. Many scientists are of the opinion that outer space is a treasure chest of gemstones. They believe that it might be raining diamonds on Neptune and Uranus. Evidence of opal on Mars hints at a watery past. Outside of our solar system, there may be rubies and sapphires too, but the gems that form within Earth still might be the most dazzling. In 2012, scientists announced that they had found a planet, 55 Cancri E, and that was made out of diamonds. The idea was based on estimates of the planet's size and density. Soon after their work was published, however, other research suggested that they were wrong. Based on what was said, they explained that to come to these kinds of conclusions, scientists work backwards, starting with the size and mass of a planet. They then move on to use that information to estimate the density and then work to determine what kind of materials could produce that density. It was further said that it's not proof that those materials are existent on the specific planet. While the entire planet of 55 Cancri E may not be made of diamonds, there is a good reason to believe that diamonds do exist outside of Earth, throughout the universe, along with other precious stones like opal, rubies, and sapphires. We can form all sorts of gemstones potentially in space, as long as you have the right chemistry in the right temperature and conditions. Diamonds are just pure carbon, and carbon is abundant in the universe. However, diamonds don't just spontaneously form anywhere that carbon exists. Particularly, a set of circumstances must exist, along with extremely high temperatures and pressures. Diamonds form in environments that lack oxygen. Diamonds shouldn't even really exist on the Earth's surface. It's not stable. He further added that a pure diamond would not survive a house of fire because the heat would help to react with oxygen in the atmosphere. If it's able to react with oxygen, it could turn to carbon dioxide or graphite and destroy the diamond. Scientists have also found nanodiamonds in 1987. These are tiny, microscopic pieces of diamonds in meteorites. Inside these nanodiamonds, researchers have since found trapped gases and minerals that give clues about when and where they were formed. For example, Uralite meteorites, a type of meteorite with a high percentage of carbon named for Novi Ure, a village hit by a meteor in 1886, contained diamonds. In those diamonds, researchers found materials that suggested that the gemstones were created inside a planetary body as old as the solar system. However, some scientists still dispute this finding and suggest that these diamonds could be the result of powerful collisions between smaller objects. They also suspect that it could be raining diamonds on Neptune and Uranus. They are conducting experiments on Earth that mimic the temperatures and pressures on these planets and found that they were intense enough to form diamonds. Then, because the diamonds are heavier than the environment surrounding them, they sink into the planet. A little like rain, the sinking diamonds generate friction, which researchers say may help explain why these icy planets generate more heat than we would expect. Like, comment, share, and subscribe. Let me know what you think about all of the matters that have been discussed: opal, rubies, sapphires, and diamonds across the solar system and in outer space as well. Extremely fascinating, and the idea that worlds were initially formed with water in our solar system, and based on their theory, these planets would contain similarities to that of our Earth. Have a good day, take care, and goodbye.